Okay, so today we're going to be making some diagrams and also making some conjectures. And we're going to talk a little bit about vocabulary. If you were drawing before rulers, we would use a straight edge that didn't have any measurements on it, and we would actually use a compass to help us make right angles, etc. And that's something that you may have done in younger grades. This year we won't be doing a whole lot with a compass and a straight edge, although it is quite fun to learn how to build those called constructions. You could probably Google it and watch some videos about how to do some constructions. Instead, this year we will use a ruler, and we're going to be working, and later on we'll be using a protractor to help us make certain degrees, etc. But right this second, we're going to use a ruler, and we're going to be using our writing utensil to be able to say what shape would best define what is the given information. Okay. So make sure you do use a straight edge or ruler, and make sure you read the directions and say, well, what figure will best answer this question? Okay, so it says points A, Q, and S are coplanar. So that means we have to take 3 points and put them on the same plane. Now, the truth is this, look at the note. It says, make sure you put them on the same plane. And normally we signify a plane by making a parallelogram. But we don't know that these points are actually collinear, so don't draw them collinear. Okay, the only thing we know is that they're on the same plane. Okay, so we try to best encapsulate what is said without taking a step too far. Okay, so the next one says point P is contained by 2 lines. Okay, so it doesn't talk about a plane. Okay, it says we have a point P. It says it's contained by 2 lines. So we would take a ruler, and I don't have a ruler on my my toolbox here, but I will say, okay, I'll take 2 lines. Oopsie, I need to get a writing utensil here. So I'm going to draw 2 lines, and the lines, remember, are a collection of infinitely many points that go forever in 2 directions. So here's a line, and then there's another line here, and point P is contained by both of them. So that point is a member of both lines. Okay, so they could have said 2 lines intersect at point P, but this is what they chose to say. There's nothing else stated, but this best shows what we're talking about. Okay, part 2. It says line T, okay, contains points Q and R, but does not contain points P and S. Okay, so if a line contains points, again, every line has infinitely many points on it, but the 2 named points Q and R. So we have to draw a line. Please use a ruler. Please put arrows on it. Name it line T. And line T contains points Q and R, among other points, but those are the named points. But it doesn't contain points P and S. So here's point P, and here's point S. Okay, so that's it. So you just have to make sure you don't put them out where they would potentially get intersected. So if you put it over here, maybe, point P, then it probably would run into point P or S. So don't put it over there. In line with which way the arrows are going either direction. So P and S should be clearly not going to be intersected by that line. Okay, the next one. Plane B. So we need a plane, okay? So draw a parallelogram. Remember, opposite sides are parallel in a parallelogram. So plane B, and you name it. Okay, so give it all the names that that you should. So plane B contains points Q, R, and S. Okay, but it doesn't contain point T. Okay, so on this plane, you should place the points. Again, we don't know that they're collinear. We know they're coplanar, so don't give it more merit or qualities than it actually has. So make point Q. We've got R and S. Okay, so those points are on the plane. Now the thing is this, if we just put point T over here, because the plane extends forever, it looks like it could get there. Okay, so what you have to do is basically put a tower, okay, on your plane. And so draw a line that goes through the plane. Okay, so I'm going to draw, put like a tower coming through the plane, and I'm going to go dot, 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 dot. I'm going to have it go below it. So that basically it's like stab a piece of paper with a pencil, okay? And have the pencil holding up this point T. So I'm going to put a point up here, and this is going to be point T. So you can clearly see point T is on a tower above that plane, and so it's not going to be intersecting that plane. So if you just place it out to the side, it probably will get absorbed by the plane. You can't better differentiate than putting a stick through that plane so it's on a tower above that plane. Okay, so this is a good way to place it. Okay, number 4, points Q and R contained in the intersection of planes H and K. So we've got to draw 2 planes that intersect at a line. Okay, so I would suggest that you start by drawing a plane like this. And then I would suggest that you draw a line going through it. Okay. And it says this is plane H right here. And let's see, points Q and R are contained in the intersection of planes H and plane K. So I could do a Q here. I do an R here. And you can draw a plane coming up out of it. Okay. And going down below it. Again, you don't have to be perfect, but, you know, we're trying to get better. I'm sure you could watch some videos and be like, how can you draw better planes? But and I would say this line right here should not be dotted. There you go. So you've got basically 2 planes that intersect at line QR. Okay. Okay, for side 2, point X is between points A and B. Okay, what does it mean if things are between things? Well, if points are between other points, that means they've got to be collinear, okay, and vice versa. Okay, so if you've got point X is between points A and B, so you got, oopsie, I need a pen. Right, we've got point A, we got point B, and you've got point X is in between them. It doesn't mean it's halfway in between, it just means it's collinear with those 2. So point X is between A and B, and point A is between X and Y. So point A is between X and Y. Okay, so and that will work. Make sure you use a straight edge when you're drawing this. Okay, the next one, point Q is on ray DE. Okay, so we've got ray DE. So that means it begins at D and it goes towards E and then keeps on trucking. So E is a directional point to say, hey, it's going towards E and keeps going after that. Okay. So point Q is on DE, but it is not on segment DE. Well, what's that mean? Well, segment DE is just the points between D and E. Okay. So it's on the ray of D to E and keep on going, but it's not between points D and E. So do you know where you should put it? How about right here? Okay, it's on that ray DE, okay, because it goes directionally forever towards E and forever after that, but it's not between D and E. Okay, all right, try the next one. And you may want to pause and see what you can come up with. AB and ray AX, okay, ray AB and ray AX are collinear. So all their points are on the same line, but they're not the same ray, okay? They're called opposite rays. So how could you draw this? Ray AB and AX are collinear, okay? So that means they're all in a straight line, okay? Both rays are in a straight line, but they're not the same ray. Okay, so if you had drawn AX over here, like this X right here, that would be talking about the same ray. AB and AX would be the same thing, okay? I know they sound different, but basically starting A and going towards B or going towards X will give you the same picture, okay? So if you have AX not being the same picture, well, they would be opposite rays, so A towards X would be a different ray altogether, okay? So they're collinear, but they're not the same exact ray. RS and RT are the same ray. Okay, so starting at R and going towards S or T and keeping on going forever would give you the same exact values of points. Okay, so RS or RT would be the same thing, okay? Because both would say start at R and go towards either S or T and keep trucking forever. AB, segment AB, and AX are not collinear. Okay, so all their points of both those segments are not all in a row. So from A to B, that would be a segment, but A to X is not collinear with it. So AX, just make it uphill maybe from it. Okay, if you go left with it directly collinear, that doesn't work. Okay, so you just need to make AB and AX not collinear with each other. Okay, intersection of rays BC and AC is AB. This is tricky. It took me a little while to figure this one out. Okay, so we can draw BC. So it starts at B and goes towards C forever and keeps going forever and ever and ever. And then we have AC. So the question is, where do we put A? Okay. So BC goes to the right and AC, so where those two rays overlap is from A to B. Okay, so there is some overlapping, and because intersection means, like, if you think about it, if they took one street and go east and west, and they take another street and go north and south, the overlap of those two streets is in that square, which is the intersection. Okay, so intersection is where they overlap. So streets overlap where they cross, okay? And so the intersection between these, say, where are their common points between these two rays? Well, between A and B. So, okay, so where do we put A? Okay, we went from A to be their intersection, okay? And so if you put an A here, okay, then that means from A towards C going this way, remember, forever, is going to be this ray. Okay, so B to C is the blue ray, A towards C, and then forever that way would be the red ray. Okay, so that would be AC. Where do they overlap? They overlap, the two colors overlap between A and B. Okay, segment AB is their intersection. Okay, so those are making pictures saying, based on what I know, what can I draw? What picture best shows this? So if you read these, we're going to be talking about, okay, can we make a conjecture? Okay, what happens when you add up any two odd numbers? What do you always get? Okay, then I would say try some. Okay, add two odd numbers together, like 3 plus 5. What do you get? Well, you get an even number every single time. The product of any two odd numbers is what? Okay, so do like 5 times 7, do like 3 times 5. Okay, what happens? You get an odd number. Okay, the square. Okay, when you square a positive integer, an integer is a number line number. Okay, not a decimal, not a fraction. So if you take a positive value like 1, 2, 3, 4, 5, etc., and you square it, what happens? It is always going to be greater than what number? 0. Okay, the next thing would be it's not always greater than itself, because what happens if you square 1? You get 1. Okay, so it's always bigger than the value 0. Okay, then the next part talks about, if you want to prove something to be true, it takes a lot of work. Okay, you have to check it to be true for every single thing. Everybody who wears pink is nice. Well, can you prove that? No, you really can't. And so listing all the cases that are possible is really not great. Okay. And listing a lot of cases doesn't count either. Okay, so there are a couple ways to do proofs, but listing out just a bunch of examples is not valid. Okay, and so we're going to be talking about formal proofs in the next chapter. But the easiest thing is this, to prove that something is false. Okay, be like, no. Okay, if you think that everybody wearing pink is nice, look at that person right there. They are mean as all as all get out. And so the thing is, you can't necessarily prove by example. However, there are ways to show, but not by just listing out a bunch of things that make it true. We want to, instead, we could do a counterexample to show that it's false. Okay, that's kind of the easiest way to show, hey, no, that's not true. So are all prime numbers odd? What is a prime number? Well, what's the opposite of a prime number? Well, that's composite. So a prime number is a number whose only factors are 1 and that value. Okay, so are all prime numbers odd? Okay. Most of them are, like 3 is, okay, because 1 times 3 makes it. 7 is 1 times 7. 11 is because 1 times 11. Can you think of a prime number that is not odd? There's only one. The answer is 2. Okay. So most of them are, but the answer is no. It's false because of the number 2. Okay. 2 is actually prime because 1 times 2 makes it. Okay. If the product of 2 numbers is even, then the 2 numbers must be even. Okay, so think about that. Is that true? No, it's not. Why? Because think of 10. Okay, what do you multiply to make 10? How about 2 times 5? Okay, so 2 times 5 makes 10. So if you multiply 2 even numbers or 2 numbers together and get an even number, it doesn't mean that both the numbers were even. Okay. The square root of a value of number x is always smaller than x. What do you think? So like think about square root. What's the square root of 16? Well, it's 4 because 4 times 4 makes it. Square root of 25 is what? 5. Okay, most of the time that's true, but can you think of an example where the square root of a number is not less than the number? Well, what's the square root of 1? Well, 1, it's equal. What's the square root of 1/4? Well, square root of 1 is 1, square root of 4 is 2. So no, it is not true. So that would be false as well. So we just talked about, can we read critically? Can we think about this? And can we learn about, conjectures? What would be true? And then counterexamples say, hey, how can you show that something isn't true? Well, show a false situation, a false example, something that proves that it is not true. All right, thanks. Have a good day.